questioning is perhaps the greatest gift we have as human beings.
Science is more than a body of knowledge. It's a way of thinking.
It's a way of thinking that teaches us to question everything we think we know.
Science came about by developing techniques, methodologies for gaining reliable knowledge about the world.
We have at our fingertips the technologies that were only possible for the largest governments and corporations 20 years ago as an individual today.
If human civilization continued at anything remotely like the current pace of technology advancement for 1 million years, where would we be? I think we're either extinct or on a lot of planets.
The good thing about science is that it's true whether or not you believe in it.
We hold the scientific method in high regard because it works. If it stopped working, we'd throw it out.
Discover the past.
Create the future.
This is the Here and How podcast.
Welcome to the Here and How podcast, where every week we dive deep into big ideas to explore the past and create a brighter future. This is episode 19, How Do Animals Defend Themselves? My name is Rachel, and with me are the wonderful Thomas Westbrook.
Hello.
And Stephen Woodford.
Hey guys.
Alright, serious question to start with. Why do animals need to defend themselves? I know it's a tough one. I know.
To survive.
So that they can eventually successfully reproduce.
Yeah, that's pretty much it. I think it's kind of important to mention that there's a big difference between attacking other animals for prey and defending yourself as an animal. So we're kind of going to be talking about the sort of defense mechanisms today, but a lot of them do kind of double up as attack mechanisms as well.
It's a really useful thing to do, right? Because if an animal spends its resources, I say spend, it doesn't choose to, but if evolution has selected for it to spend resources on say a lobster with its claws, it makes sense that it would spend a bit more resources to make it so that that can be used offensively and defensively, rather than create a whole new bit of physiological apparatus.
Yes. So, a lot of the things which you might think are purely defensive, for example, camouflage, can also be offensive as well, because it means that they can, hide away until they're ready to jump out on their prey and, surprise attack them. So, that's a kind of, two-way kind of thing. So this is going to be just, a fun, silly, very light little episode where we go through a few different kind of survival mechanisms and survival traits in animals and talk about some examples, and basically it's just going to be a bit of fun, I thought. So the first big kind of defense mechanism or survival mechanism is camouflage. I want to talk about that. So what do you guys know about animals camouflaging themselves? What does it mean?
It means that it becomes hard to distinguish visually from its surroundings.
Yeah, pretty much. Can you think of any examples?
Chameleon, I believe, is one.
Yeah.
There's various insects, I believe, that can do it as well.
Yeah, so chameleons are an interesting one because they are one of the animals who can literally change their outward appearance to fit in with where they are. So
yes. So then you've got stick insects where it's not, they can't change, it's just they've evolved to look like part of the environment.
Exactly, yeah.
I think of also animals like the praying mantis that will, resemble a leaf, but it uses it both to hunt insects as well as to avoid being eaten by things like chameleons, which are also camouflaged.
Would you count zebra or zebra as camouflage?
Yeah.
Yeah. Because it's not camouflaged against the environment unless you consider the environment its kin.
Yeah.
Yeah. Because
it's the lions have a hard time seeing the zebras and distinguishing the zebras from the grass because of their lack of visual acuity.
I think that was a really interesting scientific question to finally answer, when they thought, why are they this pattern? It's really strange. But then once they figured out, actually, it's really hard to keep your eye on one of them when chasing them, when they keep running around each other, it makes perfect sense.
Yeah. That's quite smart, actually. I didn't know that bit. That's pretty cool. A few other examples are birds like the frogmouth, which is one of my favourite birds because they have this really wide beak and they look really funny and they kind of look like a muppet, but they're birds. And they have this kind of almost like a mottled effect on their feathers that makes them look like tree bark. So when they're sat on a tree, they just look like they blend into the background. So that's one of my favourite kind of camouflage-y type animals. But you do get some animals who change their colour, like we mentioned chameleons. So chameleons are famous for it, but they're not actually one of the best ones. Their kind of whole process of colour changing is very, very slow compared to a lot of animals, like squids, for example, and octopuses. What's the plural of octopus? Is it octopi?
Octopi, yeah.
Okay, octopi. Yeah, they're really quick as well. They so depending on the species, squid are really, really famous for it. So a lot of squid are kind of like a deep reddish colour, so they can't be seen on the ocean floor and like in the depths of the darkest bits of the ocean, and they kind of like blend into the water, and people can't, I say people, other animals can't see them, so then they can kind of like attack and get away and things like that. But a lot of them also have the ability to change their colour and replicate even things like a sandy seabed and stuff like that, which is really cool.
Mm-hmm. Do you know if they've got they can excrete pheromones or some kind of other stuff that disrupts and basically when they camouflage themselves, they're making it so that they're predators, which can in most examples are using their vision. With octopus and some animals, I assume they can secrete pheromones that also make it so their senses aren't quite working as they would be in those scenarios. The only reason I ask in relation to the octopus is because a lot of the further you go down into the water, the less vision is a thing to be selected for. So it wouldn't surprise me if they also have mechanisms of that kin.
I'm not sure specifically with those guys about like secreting stuff, but I do know with squids another thing they do is they can detach limbs kind of at will, and then the limb that they've detached will keep kind of like flapping around in the water for a while, which is kind of like a distraction. So they'll like attack with a limb, detach the limb, and then while the thing that was attacking them is busy fighting this little limb, the rest of the squid will escape and run away. So it's like a distraction technique, which I think is pretty cool. And then later they can grow back a limb.
Yeah.
So
it's like, hey, here, have an arm.
Yeah, pretty much.
What
do you think? If you could detach limbs at will and grow them back, would you?
If the alternative was being eaten alive, yeah.
Yeah.
What about just for fun?
I think of the show Arrested Development, where there's like the guy who's missing an arm, and he'll like detach his prosthetic to like teach kids a lesson. Just randomly, your arm just like falls off.
That would be amazing. Another kind of like method of sort of like camouflage and stuff that I want to talk about is animals who resemble other animals, particularly like bigger animals. So butterflies are kind of infamous for this, especially like the peacock butterfly. So this is a kind of amazing one because on the underside of their wings it's kind of dark and grey and it looks a lot like tree bark, but on the kind of inside of their wings it's really bright and colourful and red, and they have these big spots on it that look like eyes, and a lot of people say it either looks like a kind of bigger animal or an owl face. So the idea is it makes them look bigger than it is to scare off would-be predators like small birds and things. So can you think of any other examples of animals who try and look like other animals to scare other predators away?
Well, I know that there's like different flies that look like bees. And you have like the snakes that look like coral snakes, but the ring pattern is slightly different.
Yes.
Same with frogs. You get frogs that try and look like poisonous frogs, even though they're not. I'm just thinking that, correct me if I'm wrong at all, but so far as for that butterfly to exist with that particular pattern on its back, the selection that must have happened, the pressures, evolutionary speaking, are really quite horrific. So one of them is just born with a genetic defect where the pigment of some of their wing is a different color, and it somehow gave them an advantage.
Yeah.
And then those genes are locked in until more mutations occur, and just over an enormous amount of time, so many generations, you have this development of what looks like another species, an apex predator in this case, with an owl.
Yeah.
It blows my mind that, I mean, it's just crazy the amount of death that must occur in order to have that final product, as elegant as it is mental.
It's a little bit scary to think about, isn't it? Because
I don't know. Yeah, I was just going to say, I don't know how someone can believe in a loving God and somehow square that fact.
Yeah.
There's got to be a more loving way than have it produced by basically murder. It's crazy. It blows my mind.
Well, this was another thing I was going to talk about, was this kind of like how have they evolved to get here to this stage? So you guys know the whole story about like the peppered moth around, in like sort of industrial era where. Well, do you guys want to talk about it actually? So it's not just me talking at you.
Well, you correct me if I'm wrong at all. So far as I remember, there was a lot of white moths in an area in England, I think it was, and then there was
London and big cities.
Was it the plague or something? Something caused the city to go dark.
It was industrialization.
Industrial
revolution.
Revolution was putting soot in the air.
Yeah, and so all of a sudden the environment's a different colour and they're white, so they're going to get picked off easily by predators because they're going to see them.
They were kind of white with blackish little spots on them, but kind of really small spots. So beforehand, they did kind of blend into the trees in the background.
And you know the spots on them might have had something to do with the same process that zebras have, in the sense that when they're flying together, it's really hard to keep track because of that pattern. But with the soot being, in the atmosphere, the birds mainly could pick them off easily, and so all of a sudden, the moths that are able to successfully reproduce are the moths that are necessarily a little bit darker, and then the birds that are, or the predators that are able to reproduce, are the ones that actually can catch the moths with their eyesight, and so you have this co-evolution where over time the birds get better and better and better at seeing, and the moths get better and better at being inconspicuous among that environment. And so the end result is that you have black moths, and that is pretty much what happened. Yeah.
I find it strange that people try and deny evolution when we've literally seen this within the last few hundred years. Like it's such a small thing because it's not like it's not exactly like they've grown an extra limb in that time, but there has been a huge change in the genes which has benefited their survival. And I'm like, how can you deny evolution when we've seen it?
So a lot of them do it via this micro-macro distinction. So they say, okay, I acknowledge, I have to acknowledge, because I see what we've done with dogs over several centuries, that if you breed for certain traits, if you breed for certain things, if you control the selective process, you are going to get a difference.
But I feel like the people who make this distinction don't really understand what macroevolution is. Yeah, because they seem to think it's like a dog giving birth to a monkey, and it's not. Yeah. It's not. Simply microevolution over a much, much bigger, longer period of time. So the genetic change is bigger just because it's stretched out more. You know?
Yeah, an example of that is the crocoduck that was put forth by Kirk Cameron and I think Ray Comfort, where they said, you'll never see a crocoduck. It's like, of course not. What you see is you see crocodiles that, as you go further back in time, they get gradually smaller and smaller and smaller and less scaly and less scaly, and like there's no point at which it's like obviously another species. It's just like these tiny genetic changes that it just slowly gets smaller until it gets back to a common ancestor. Now ducks and crocodiles, they're not really closely related at all, but they do share common ancestors that have common traits. And so you go back far enough and you get a creature that's, smaller and, probably, aquatic and whatnot. And, I don't know too much about the lineage of either, but it's just, that's not how evolution works, that you're going to see an animal that's like half one thing, half another, like some type of weird mutated hybrid.
Do you guys happen to know whether or not synapsids evolved from reptiles?
I don't.
I was just going to say, because if my memory serves me correctly, and it might not, I just want to caveat that mammals come from synapsids, and synapsids then were related to reptiles. So if you wanted to find the common ancestor between a crocodile and a duck, you would have to trace back the lineage really far, to the point where it probably doesn't look anything like either of them. It's a bit like if you took an orange and a human and you said, well, we should get the orange. Or, it's like, that's not how it works. But we do have a common ancestor. You just have to trace it back, and all the evidence is showing this.
Yeah, but when it just probably diverged way back at some like eukaryote right before, photosynthesis evolved.
Yeah, whereas if you take a coyote and a dog, which, say a coyote and a Great Dane.
You call it a coyote?
Yes. What do you call it?
Coyote?
Oh man, that might just be me. Quickly, remove this. No, keep it.
Sorry to cut you off.
No, you should cut me off. So
I thought I was
say
just
it again.
mishearing at first.
So I said what
coyote.
Coyote. Okay,
Coyote.
not quai. Okay.
Didn't think so.
So no, you're right. If you take a coyote and you take, say, a Great Dane, I'm saying that one right, yeah.
Mm-hmm. Yeah.
So far as I know, they can't mate successfully.
I don't think so.
So they're different species.
Mm-hmm.
But if you take both and you say, "Oh, there's got to be a common ancestor," you probably it's really close. Whereas it's not close between a human and an orange. But when it comes to the microevolution, macroevolution distinction, a lot of theists that I've dealt with, they can't really deny the fact that there's micro changes. And they can't really deny the fact that you can select for it and that nature can select for it without a mind being there. So they kind of appreciate that, yeah, you don't need a mind to get more complex, organized structures. But then they do say that macroevolution doesn't exist, which means that one species is always going to be that species, but it will change a lot. Of course, we know this is stupid because we've bred rabbits, for example, and now the Alaskan rabbit cannot successfully mate with the is it the Minnesota rabbit?
Something like that. It's ring species.
So they cannot mate anymore. They cannot mate at all, and yet they can mate with other ones. But if you took out all the other rabbits, you now have two species. They cannot mate, and we know that their ancestors could because we bred them. So that's macroevolution. Yeah. They can't successfully reproduce. So yeah, it is the difference between macroevolution and microevolution is essentially time.
Yeah.
Yeah. Well, and they'll always break it down and be like, oh no, like you can't, they're still the same kind. They're still the same rabbit kind or whatever. And I don't know a single biologist that even has ever heard the word kind.
Yeah.
And every single time that you try to pinpoint and ask them, people like Kent Hovind or Ken Ham, what a kind is, they can't really define it. They just have this idea of like, oh, there's a few animals like dogs and rabbits and birds. But even within those, there's so much divergence and there's so many different overlaps. And you can go all the way back with different intermediary species, to link back between different animals and find the ancestry.
Sorry, go on.
I was just going to kind of like slightly change the subject a bit and say like the thing that really gets me is when they say like, oh, well, you never see these kind of, what's the word? Like sort of transition, either species or things. Like I had one person leave me. No, so I had one person leave me a comment saying like, how could something like the eyeball evolve? Because you can never just have half an eyeball, or it won't work if such and such a thing isn't there. And I'm like, look at blind people. Look at people who need glasses. They're people who have like these deformities in their eyes, but they still technically work. They can still kind of see. It's just not working properly. So you take out the small bits and like work your way backwards, and you can see how the eye would have evolved. First you just need something that can pick up light. Then you need something that can start to pick up sort of like basic shapes and outlines and see in a bit more detail. Then something that can see colours, then something with a lens that can focus, and then muscles on that lens that can move the lens to alter the focus, and then you get a working eye. You know what I mean? It's just...
I know Dawkins has done some incredible visual examples of, the different stages of an eye, like photoreceptors, and then like a simple curved basin, that could detect light at different angles and stuff. But I always, whenever I hear like, oh, that's microevolution, I'm like, well, okay, that's saying you believe in microevolution but not macroevolution is like saying that you believe in drops of water but not lakes. Drops add up over time and you get more and more and you get bigger bodies of water. Micro changes add up over time and you get bigger and bigger amounts of changes until you have something that's completely indistinguishable from what you started with.
It's like, I believe in rainfall and I believe in rivers, but I don't believe in the sea because it's just insane. No body of water can be that big. Yeah.
Because God. Can I, real quick, I know we moved on a little bit from camouflage, but there's a couple things. So like we talked about concealing camouflage where they kind of blend in with the background. We talked about concealing coloration. We talked about disruptive coloration where like zebras, it all kind of blurs together. It looks like one big thing rather than multiple zebras. And then we talked a little bit about mimicry, like animals that will look like a leaf or they look like something else. And there's I also wanted to touch on non-visual versions of camouflage that are kind of cool.
Yeah.
So one of them is auditory. So, for example, there's these different moths, like the tiger moth, and this is like the noctuid moth. There's two different ways that they'll defend themselves against like bats that have echolocation to try to find and hunt these moths. And one of them is like having fur-like body coverings, like little fluffy feathers that actually absorb some of the noise that the bats, like the chirping or whatever that the bats make. And so there's less echo. And so they try to absorb the noise to hide from the bats that way. And then another one is that some of them will actively make noises that will mimic the sound of the bats to throw the bats off.
That's amazing.
Yeah.
I thought that was kind of cool.
There's some really birds, birds of prey that have learned to make, to make sounds that are like their prey. So they can make the sound of, like a sexual attraction, and the bird will come, and it's not the kind of sex it was hoping for.
Unless they're into that,
Yeah, that's some serious, that's some spider level stuff.
Speaking of like kind of mimicry, this is a really like bad sort of transition. Speaking of mimicry, the next thing I want to talk about is animals who pretend to be dead as a kind of defense mechanism. So, opossums are a big one. They're kind of the common one that's well known. But apparently snakes can do it as well. And one of the big things they do in order to fake being dead is not just lay there and not move, but they literally release kind of like either a fluid or a gas that smells like rotting flesh.
Wow.
So they do that to trick their predators into thinking, oh, well, this is dead, this has been here a few days, it's going to make me ill, I don't want to touch this.
And to attract vultures.
Well, that's actually an interesting point. Like, just because it repels some animals, then, like you say, what if it did attract vultures? Then it would backfire. So maybe this only evolved in species living where vultures don't live.
Or it just gets swarmed in ants.
Well, some vultures would come, but let's say in the scenario, and they would look down and see that it's flesh, when really a lot of vultures don't like flesh. They've evolved to like gristle and even bone, with like the lammergeier, for example. It can only really digest bone marrow. That's it. Oh. It's crazy evolution to be able to be in that state. Yeah, humongous bird. Wow. And lammergeier. Again, I might be saying the name wrong.
That's all right.
I don't think so. But yeah, fascinating example of evolution. It's evolved to a state where it consumes bone marrow.
Wow. The bone marrow of coyotes.
Yeah, of coyotes, exactly.
Sorry, I had to. But that's interesting, though, that they would secrete gases to chemicals or something to smell like dead flesh.
Yeah.
Because there's also like olfactory camouflage where some hunters or some animals will, like, there's different insects and spiders that apparently will mimic the pheromones put out by ants that either to hide from predators to mask their own smell, or to attract and hunt ants to get ants to come to them.
It gets really bad with pheromones for ants, because pheromones play a role in species with a large brain such as humans, but they don't play an enormous role, whereas pheromones are everything for insects. Really, that is the way that they have the hive mind, as it were.
Did you ever see that guy that he got an ant to do a little loop in a bottle and then let it go, and then left like the bottle cap open, and all the ants that came afterwards to the food source would go into the bottle, do that loop around, and go out, and some of them got confused and kept going in circles.
That's insane.
But they're literally just following a trail of pheromones.
Yeah.
That's amazing. That's so
really
cool.
Cute.
I was going to say another example is what they refer to as animal hypnosis. So if you take a chicken, for example, and you handle it a little bit aggressively, which I obviously wouldn't recommend, or you put their head to the ground and you draw a line in front of it very quickly, they just stop. They can't move. They're paralyzed. And if you then move them they will often get up and run. But in that state, they are in a state of paralysis. And evolutionary, this sounds like a what the hell is going on there? That's not smart at all. That's got to be some kind of unfortunate mistake or a byproduct of something else. But it's actually been selected for. So if a fox picks up a chicken and the chicken goes limp, and the fox puts down pressure, and the chicken is still limp, it can infer, even though it might not do it intelligibly, that the chicken's dead, and it can drop it and chase another chicken. But the act of dropping it, the FUD, etc., will make it wake up from its state of paralysis and live. And so it's selected for.
What about, do you know with sharks why they do that? Because there's different orcas that will hunt sharks, and they knock the shark and it flips upside down, and when it's upside down, it like goes into a temporary state of paralysis.
I've got a feeling that that's not so much a defense mechanism, but more an exploitation on the orca's part of the way in which sharks have evolved.
And what about the fainting sheep?
Oh, I was just going to bring these up, the little goats. They're so cute. Oh my god, have you seen them? It's like
not really.
As soon as they get a little bit scared, they just go like completely stiff, like their legs freeze up and they just fall.
There's an amazing video of a guy. It's, you guys know Skyrim, the you know Dragonborn like Fussrodaw like speech that will like push things back and stuff. And like there's this video of this guy that like has that music building up and he goes Fussrodaw, and all the like the sheep just like get paralyzed and fall over. It's amazing. We'll put it in the show notes on our site.
Yeah.
They're so cute though, because I imagine it's a very similar thing to the chicken thing maybe that helps them.
Yeah.
Or the other thing I'd say is that if there's a predator who kind of doesn't have very good eyesight but tracks movement, going completely still would kind of render them invisible.
Yeah.
Until they fall over.
I think it is a state of paralysis just caused by the same thing as the chicken. It's like instead of a fox, it's a wolf that's got hold of its leg and it will just drop. And the wolf might, because it's it's in a feeding frenzy, it will then go, okay, let's grab another one, let's make this meal bigger, and that might give it an opportunity to escape.
Animals just kind of blow my mind a little bit. I love this stuff. Alright, the next thing I want to talk about is less the kind of way they act and more like inbuilt physical little defense mechanisms. So things like spines and spikes and stuff like that. So a lot of lizards have kind of like spiny scales. Pangolins, which you all know are one of my favorite animals, have these amazing like scaly armor around them, and they can roll up into a little ball and protect themselves, and they're like nearly impenetrable. Things like turtles, their shell is almost impossible to penetrate by any predators. So yeah, I was just wondering, do you guys have any examples of this, like little physical defense traits?
You know, I've got my mind fixated on the turtle thing there. For it to be so strong, such a hard force to get through, it must have co-evolved, right? There must have been something putting more pressure on it to get even stronger and stronger.
I'd imagine so, yeah.
Because it wouldn't just get stronger for no reason, unless maybe sexual selection or something got involved.
Potentially,
I'm just wondering, like, what are their predators? What's made it so that is it some kind of, raptor with incredibly powerful talons or something?
Well, turtles are really old, aren't they? Like, in terms of evolution, like they haven't really changed much for a long time. But if you think back to kind of when they were still evolving and stuff, a lot of the animals that lived in the oceans then were huge. Because think about the oxygen content, it made them, like, in the atmosphere and the water and everything, like, it made them bigger. So think about the jaws on them.
Yeah, I see. That's a good point, actually. Yeah. Because they've had it for so long, you can look back and
turtles, they existed at the time of the dinosaurs. They survived the meteor impact or whatever. Or volcanoes.
They're really old, aren't they?
So considering
go listen to our episode about mass extinction events.
Yeah.
To find out what killed the dinosaurs.
It was turtles.
No!
All the way down.
Yeah. So yeah, I guess we kind of won't know what it co-evolved against, because we might at some point, we might get lucky, but really they co-evolved with something back during times way before today, and it's just because they haven't had the need to adapt and change. They're very successful still. They still have this overpowered shell.
That's true. That's why I guess like they can live so long now, because they don't really have many natural predators. You know, one of the biggest threats to turtles is people.
Pretty much, yeah. And just waste, plastics and stuff.
Yes, yeah. Oh, I saw this horrible video about this poor turtle who he got his head stuck in, like, you know, one of the like plastic bits that like a 6-pack of cans comes in. Like he'd got his head stuck around that when he was young, and then as he'd grown, it had kind of like stayed the same size and stuck around his neck, and it was like really restricting his airflow, and it was so sad. And I was like, oh, the poor baby.
Yeah.
It made me sad.
I saw one where a couple where they get the turtles out of the sea, and then they basically have to pull plastic bags out of their nose, and it's like completely lodged in there because they thought it was a jellyfish or something. It's like,
oh baby.
It's horrible. It's absolutely horrible to watch.
Stuff is heartbreaking.
It makes me recycle. Put it that way, as much as I can. I don't want to.
I think I've told you guys before about I think it was when we were on holiday in Crete, and the hotel had like a big policy of like after a certain time you weren't allowed to have any lights on one side of the hotel because it distracted the turtles and pulled them inland instead of out to sea, which meant like as in they would walk towards the light.
They usually follow the moon.
So they got confused and they would walk inland on the island instead of out to sea, and it would.
It's like after hatching a lot of baby turtles.
Isn't that amazing, right? They've evolved, you know, their entire capacity when they're born, especially like when you take moths and stuff like that, to be able to navigate via the moon. It's all to do with there's only going to be one source of light. This is what you've evolved towards. And then
millions of years of evolution.
Yeah, millions of years of it. And then, you know, in the space of like 100, 200 years, all of a sudden some other species starts producing artificial light, and you're fucked.
We ruin it.
You were completely fucked because you are not prepared for that in any way, and it's devastating. It's insane.
Plot twist: Thomas Edison hated turtles.
I knew it. Like it does sound barbaric when we put it like that, but at the same time, it does mean that once we understand these things, we can kind of exploit them for our own good. So, like, you know those fly zappers? They work because flies are obviously, like, attracted to the light. So, they go up to them and then zzz. And that's kind of like a thing for our own benefit. So, by understanding these things, we can kind of utilize them, even though it's not always in the most friendly way.
Yeah, I mean, bear traps. You know, you put down a trap because you know that animals will roam in that area. You're going to, you know, hurt an animal. And you can apply it to humans, you know, it's just all about motive. You need to know what people are doing. If there's a village and you're looking for someone and there's only one source of water, wait near the water, they will come.
That's true. Oh, it's kind of scary
or,
to think
you
about.
know, if you know how humans think, then you can market and manipulate them psychologically.
And you should check out our episode on that.
Shameless plugs all the way through.
To be fair, we've kind of got to the point where we have like delved deeply into certain topics that we kind of bring up in subsequent podcasts. It's quite cool.
Yeah, just wait till we're on our 500th episode. We'll be like, well, the only thing we have left to cover is quantum entanglement. None of us know anything about that.
Yeah, I do fear this. We'll get to a point where it's like none of us are confident enough to take on the topic.
Well, then we'll just start having guests on.
Yeah, guests. Come on. Exactly, yeah.
We'll be like, here's our guest. He's specialized specifically in this particular type of quark, and when it's floating in this medium of yada yada whatever. Insert complex scientific phrasing here.
And he just talks for an hour, and we're just sat there open mouthed, like, yeah.
Like, did he get any of that?
It's like, well, I understood the word the.
Spin.
Yeah. Anyway, back to animals. A big one is things with spikes. So, like hedgehogs and porcupines. And while I was researching this, all I could think about was, you know, that Roald Dahl story in, I think it was Dirty Beasts, and then there's the girl who goes and she's eating sweets and she sits on a rock every day, and then one day she sits on a porcupine and it spikes her in the bum. I don't know why I felt the need to share that, but that's all I could
It's like
think
when
about.
you think you're having a bad day, be grateful that there's not a porcupine quill in your bum.
Exactly. Like, I do think that would be painful, though.
Yeah.
One of the grossest animals I found that kind of makes use of this sort of stuff was what is called the Spanish ribbed newt. And basically, it looks like a normal newt, but then if it's ever under attack, it will literally shift its ribs forward at this angle and push them out through its skin to create these spikes on its body. And then afterwards, I'm not entirely sure how. I think maybe it manages to like suck them back in or something, but it does like no long-term harm to the newt at all, and it just makes them all spiky. So if someone tries to eat it, they get a mouthful of spiky bone ribs.
Wow.
That is
Yeah.
Yeah, wow.
Well, it's like the little blowfish that like, or puffer fish or whatever that like will puff way up and
yeah.
put the spikes out.
It's like,
But-
so they look really tiny and then they blow up and it's like,
Yeah.
good
You know,
times.
I've always been grateful that like my girlfriend isn't a porcupine.
Is this something you think about a lot?
I mean, not on a daily basis, but
But on a monthly basis?
well, think about it. Like, what if you were like, you know, you wanted to give someone a hug and they were covered in like prickly quills and stuff.
You clearly
couldn't
never
really-
hugged a man with a beard.
Not wrong.
Does Dan have like poisonous little spikes on his face that?
Not naturally, but sometimes when, you know, his stubble's growing back, he'll rub a bit of poison in, so if I get too close.
Keep back, I put cyanide in my beard today.
But no, I think it's kind of amazing. We've already spoken about, like, squids and stuff and animals that literally break off limbs. Dormice do that with their tails as well. They can detach parts of their tails if they get caught, which is crazy. A lot of lizards do it as well, where they can lose a limb or part of their tail, which I thought was quite cool. Can you think of any other kind of, like, armor in animals? If that makes sense?
I mean, shells for like snails and slugs, or not slugs, but like snails. Any kind of like the trilobite, you know, was kind of one of the original developers of these, you know, calcium-based shells. Yeah. But if you think about it, our entire skeletal system, our bones are, you know, a structure to give, you know, to make us harder to eat and more, you know, solid and you know, it's just some animals have that skeleton on the outside, so you can't eat the walking bag of meat off of the bone.
Yeah, you're basically a brain and a spinal cord, and everything else is in some form or another armor.
Yeah.
Or food.
Or food, yeah.
Or a way to run away.
Mm-hmm.
Yeah. Other things like cockroaches have their like little hard shells and stuff like that.
Exoskeletons, beetles.
Yeah. So I thought that was pretty cool. The next thing, kind of following on from this, I want to talk about is more like natural weapons. So we're talking like claws and strong jaws and sharp teeth and stuff like that. So this example is like my favorite one, right? This is disgusting, and I found a video of this that I'm going to send you guys afterwards, and I'll put it in the show notes because it is revolting. Not exactly like a weapon, but a great little, not even a great defense mechanism, but a strange defense mechanism that I thought fit in here. So there's a lizard called the Texas horned lizard, who, he literally has little horns on him and little spikes. You know, he's covered in these, so you don't want to bite him. But if anyone does come up to him and tries to eat him or attack him or he feels threatened, he will literally squirt a stream of blood from his eyes.
Yeah.
It's revolting. This stream can go like 5 feet forward, and it's mixed with this like foul tasting and foul smelling chemical that like wards off predators. And I think, yeah, they can release up to 1/3 of their blood at a time.
Wow.
It's insane. Like, the videos of this are revolting, but so impressive.
Yeah.
Just want to share that.
That's awesome.
Yeah, that's one hell of a defense mechanism.
Yeah.
Very costly.
Yes.
I also think of like the fish that spit out of the water to like hit insects and knock them off limbs and eat them.
Yes.
Of course, they're not, you know, using 1/3 of their blood. They're surrounded by water, so it's not like a scarce resource. That.
But it's a bit like venom in snakes. It's not cheap to produce venom.
Yes.
It's expensive.
Yeah.
it's expensive in the sense that it's expensive to a snake, because snakes, quite famously or notoriously, however you look at it, can eat once a month, and that's it. And that's of course because they're cold-blooded, and so they don't, use energy like we do, and they don't have the brain. Our brain uses a tremendous amount of calories.
Some of us.
But a lot of snakes, they deliver dry bites with most of their bites, which basically means they don't actually secrete the venom because it's really expensive. But when they want to kill, when they want to eat, they will release that venom. And there's a lot of animals that have similar mechanisms. Octopi, they're releasing off ink, as it's called. That's not cheap to make.
No.
That costs them time and money.
Skunks as well. So skunks release, the little spray from their butt, basically, near their butt, and this contains this kind of substance called thiols, which are sulfur compounds, and basically it just smells really, really disgusting. But in some animals and in large quantities, it causes headaches and burning or stinging of the eyes. I'm just reading off my notes here. But what's really cool is, well, not even cool, but what is kind of a problem is that they can hit a target 10 feet away. Sometimes it's been known to hit a target up to 20 feet away. So they have to release a lot at a time. Wow. And when they release, they don't often have control over how much they release. So often they'll just get rid of all of it at once. And then it can take them 10 days to get any a decent amount back in their system. So, like you say, it's costly. And then after that, for 10 days, they're kind of defenseless. So they've got to be really careful where they use it. They can't just go around spraying everything. So if a skunk ever sprays you, it's your own fault, and you clearly did something to annoy it.
Yeah, you scared it.
Yeah.
Or if you hit it with your car, you usually will get sprayed.
Yeah.
I think it was Amanda that was telling me, my girlfriend was saying that she hit a skunk a couple years ago crossing the road and got sprayed on their car, and it's so hard to get rid of the smell. And so and apparently the smell of skunk kind of smells like weed a little bit.
Yeah.
So then they went to the drive-thru at this restaurant, and as they pulled up, there's this stoner dude at the window. He just opens the window, is handing him their food, and he looks at him and kind of grins. And he's like, yeah, nice.
Oh, bless. Gotta say, I think there's definitely a skunk living downstairs from me then.
Oh, you can't call your neighbours that.
Alright, another really cool weapon that certain animals have is the ability to deliver electric shocks. For example, the electric eel. Do you have any idea? So they basically have these specialized cells which they kind of store electrical power in them, and then if they're threatened, all of these cells kind of discharge the electrical energy at once. Any idea how many volts they can kind of deliver at once? It's more than I expected.
I haven't got
more
a clue.
than one, because she said volts.
I'll give you a clue. It's in the hundreds.
600.
Oh my god, yes!
601. Ow.
How did you know that?
I just guessed. I remember hearing it a long time ago that it was it's more than the typical 220 wall outlet voltage in Europe, but it was it wasn't thousands.
Yeah.
600. What would that do?
I don't want to know. I'm not very knowledgeable about electricity and what it'll do to someone, but
I mean,
it's
your
more
muscles
than
would
I would
tense
want
up.
to test.
Do we know what a taser is? How much a taser delivers?
I think it's more than that.
Because a taser completely, incapacitates someone. And it's a rough time.
A taser
if it's anywhere
apparently
near
is.
that.
This is weird. I just Googled it, and it says Taser International says that while its device can deliver up to 50,000 volts
Jesus.
in an open air arc only, it does not deliver that much voltage to a person's body. The company says that it delivers an average of 1,200 volts.
and that's that puts most people on the floor. They're in trouble.
But still, like if you're getting hit with 600 volts, that's enough to make your body tense up at least and kind of draw back. Like, have you ever been shocked by like a wall outlet?
Yeah.
You just kind of like your body kind of freezes and then jolts backwards.
The worst I've had was like a shock from a battery in a disposable camera. That's the worst that I've got, but that was painful. I screamed.
Yeah.
Because I'm a gun. Alright, what else? Oh, okay, this is a fun one. Back to like poisons and chemical weapons and things like that.
Venom.
There is an animal that looks very, very, very cute, but has poison glands in their armpits. So when they are threatened, they will literally release this poison from their armpits and coat their whole body in it, and even their teeth, so that if they bite anyone, or if anyone bites them, they'll be poisoned. And before they go out like hunting for food, if they have any young babies, they will cover the baby in this poison too, to kind of protect it from predators. Any idea what the animal is? I know I'm not giving you much.
Well, I guess it has to be a mammal.
I think it is, yeah.
I think...
It's
Was it my old roommate? Because he always smelled really bad after he'd go running.
Oh, it could have been. I'll tell you this. It's a very cute little animal with really big eyes.
Is it like a squirrel kind of thing? Like those... That little...
Kind of. A little bit more exotic than a squirrel, though. You won't see them in Greenwich Park.
Those little, like, marsupial things that jump from tree to tree that have, like... Or maybe it's like a little monkey.
You're getting there. You're getting there.
We're close. A lizard. No. Yeah. I don't know. I can picture it, but I don't know what it is.
It's a slow loris.
Oh, yeah.
Yeah, those are cute things.
Aren't they exclusive to Madagascar?
Possibly. I'm not sure. I can't remember off the top of my head. I know they definitely, at least some of them live there, though, I think. I don't know if they are exclusive, though. Saw one in London Zoo.
Yeah, so they're obviously not all on the island.
Exactly.
Oh, yeah. Have you seen... I was just looking these up. Have you seen the little video of the one that's... he's like being tickled or whatever, and he like keeps like putting his arms up? It's like...
Yeah, he's releasing poison from his armpits.
There's like... He looks like he's smiling, like, tickle me!
But really, he's actually... like, I'm poisoning you.
That's hilarious.
Have you seen the video of the one eating the little ball of rice, though?
I think so.
Oh my god, it is so cute. Oh, it is adorable.
Links in the description.
Yes. The last little chemical weapon I want to talk about is from a bird called the Eurasian roller bird. And he does something very disgusting to ward off predators. Can you guess what it is?
What type of bird?
Eurasian roller bird.
Implies that it pisses.
It's not.
He rolls up poop. Well, there's frogs that pee on you and you like pick them up.
Yeah.
Isn't that just like most animals, or do animals
like
just
monkeys? Monkeys like throw poop.
Oh, Dan once had a tamarin nearly pee on his shoulder.
Huh.
That was fun.
I thought you were about to say, "Oh, Dan also throws poop."
Well, he does, but you know, only
my
on
sister
weekends.
got bit. There was a spider monkey. This guy had like a little spider monkey in the park, and she went down. She was like a little kid. She went to play or to look at it, and it like jumped up and like chomped into her lip and like bit her.
God. Well, that's terrifying.
But what does this bird do?
It vomits on them.
Oh.
Like a proper projectile vomit. Like, not just like mixed up mushy food mess, but like mixed with these like foul smelling chemicals, so it smells really bad. Just like this projectile yellow vomit from its beak. Imagine this tiny bird just... Isn't that nice?
Flies
hitting you with a torrent of...
Yeah, I'm not mistaken, flies do the same. They basically sick up acid onto what they want to eat, and then eat the acid back up with the addition of whatever it's corroding.
But that's not really a defense mechanism.
No, but it just reminded me of the the way that vomit would work and the way it would be related. So with the bird throwing it out as a weapon, or even as defense, we kind of, have come to a conclusion that most of them, they overlap, right? Yeah, I guess that fly wouldn't use it as defense. But it's attacking its food.
Yeah. More offense than defense.
Yeah, it's true.
Yeah. Can you think of any other kind of like weapons other than like big claws on lobsters or bears?
Like poison dart frog, doesn't it shoot poison darts, or is that just the?
No, it secretes poison from its skin, I think.
Oh.
Yeah. But they are one of the most poisonous animals.
Darts.
Oh, that would be so cute. Just like for its little fingers, it's like pew pew pew. Pew, pew. Sorry. Getting carried away. But doesn't it make you feel like, as humans, we have some pretty, like, terrible defense mechanisms compared to some animals? Like, natural defense mechanisms, not like a gun.
Yeah, but I don't know, but I think to some extent, like, we are... There's a reason that we're an apex predator, and it's because every single one of these defense mechanisms we can make. Like, there's no animal in the animal kingdom that can just decide, you know what I want to do? I want to make poison. But you can have, like, a chemist that goes into his lab, recreates, certain poison cocktail chemically, and creates, poison darts, or creates, camouflage, blacksmith creates, like, armor or something. And, every single one of these things, like, we can use and we can adapt, and we can be like, oh, that's cool that the animal does that. Well, I'm stealing that idea, and I'm,
and
culturally appropriating this idea.
we can get better.
I guess it would be species appropriation.
Yeah. Well, it's weird. If you look at humans as an apex predator, it was only when we really start, I don't know how far back, no more than 3 million, maybe, Australopithecus afarensis, etc. Until then, we weren't really an apex predator at all. We were at the mercy of big cats, dogs. We just, we were doing okay, but we wasn't doing great. There was a point where we went down to 10,000 humans left, evidently. That's ridiculous. That's near extinction. And that's why humans basically still look so much like each other, because, we were nearly gone.
There's so few left to breed.
Yeah, but it seems like a mixture of dexterity, our locomotion of bipedalism, because we have a massive arse compared to other apes. Our arse is massive.
Speak for yourself.
Okay, I have a JLo arse. And
I'm rocking the Kim K. That's why I sit down in my videos so people don't see me.
I just don't want people knowing that my bottom half is 10 times the size of my top. But with the defense mechanism being able to be a little bit smart and being able to, infer certain things, and I found food there, maybe it will come back again when it's sunny. Oh, it did. That's great. As soon as that developed, it evolved to a state where we could start applying that to, actually, let's make weapons, or let's do this, or let's do that. Yeah, we go from, something not that special to the apex predator, because we can start replicating what takes millions of years of evolution and necessarily death after death after death because of the selection process. We can do without death, and we can do it with our mere conceptualization, and we can create the next version as soon as we test it and see how can we make it stronger. That's a very, very, very potent weapon.
Yeah. Well, I think one of the biggest evolutionary defense mechanisms is the ability to build cities. We build up these entire areas where it's like within this well-lit, walled area that's, policed, and that has people with, defense mechanisms and guns and whatnot, that in this area, animals, predators know that if they go there, they're probably not going to survive. Like, maybe they don't know, like, consciously, like, thinking about it, like, oh, I'm not going to go there today because I don't want to die. But, like, they have this built-in fear of humans, of going into cities. And some places, you'll see, like, tigers and whatnot will wander into, like, different parts of India. If, like, they're hungry, they'll wander into, like, cities. But even then, it's oftentimes you'll have hunting parties that will go and hunt down the tigers in the area after something like that happens.
Yeah. Even at the moment in like Australia, where you just have a brown snake. Sounds like such a lovely name, brown snake, but it's the second most venomous snake on earth. Trust it to be called that. It's just like, what should we call this mega deadly animal? It's brown. Yeah, I call it a brown snake. Okay, brilliant. They have those come into some of their areas, and I don't know what they do, but I imagine for the longest time they just kill them. But it's interesting. Social species create these maybe this is the wrong term to use considering the current climate, but they create safe spaces. And, you know, as soon as we were able to do so in a more proficient manner, you know, it's a brilliant defense. You can let your guard down and relax. You know, ants do it. You know, if
beavers build dams and
and if
termite mounds.
Yeah, if you drop an insect that isn't an ant into an ant's nest, I don't think it's going to go well, unless it's got special pheromones, of course, etc. Yeah. But it's not going to go well. They'll kill it and get rid of it.
Can you imagine like a termite mound when like an aardvark or whatever, an anteater comes up and it's like just clawing, like destroying these skyscraper towers? Like it's got to be like Godzilla to them.
Well, often they don't. Well, if you take something like a pangolin or an anteater, they don't always just go straight in with their claws. They'll be sneaky about it, and they'll go in with like they have really, really long tongues. So pangolins in particular, their tongue is literally the length of their entire body, and it's kind of like attached really, really far back in the body, so it can stretch out like a really long way, and it's really, really sticky as well. Their saliva, so they put their tongue in the hole. And then they just weave it around in like a little maze, and they just pick up ants and rocks, and the rocks help with digesting the food because they don't have teeth. And so it's just like, you know, just stick your tongue in, wiggle it around, bring it back out, swallow. Stick your tongue in, wiggle it around.
Oh, Rachel, what the
hell? Phrasing.
Fuck's sake.
That's just going to be our here and how short this week is just, you know, stick your tongue in, wiggle it about, you know, you might get a little bit of dirt, but
oh my
pull it out and, you know, everyone's a winner.
I don't know what you're laughing at, guys. Filthy minds.
You win the podcast this week, Rachel.
I mean, we are part of the animal kingdom, so
yeah.
We're just a bunch of animals.
We are.
We're animals, I tell you.
Is what you just described a defense mechanism or an attack?
It's definitely attack.
Yeah, it is.
Yeah. Guys, would you have a tongue like a pangolin if you could?
If I could?
So would I want a tongue that attaches basically to my bladder?
And it's super sticky and long and really textile, but it kind of looks like a noodle.
There would be very small amount of areas where I could see that being useful.
Eating ants.
But other than that,
it would make eating milkshakes a lot easier.
Yeah.
Like when you get down to the bottom and there's like a little in the bottom, but you don't want to be like rude and like use your straw and be like make slurping noises. But if you just have a tongue that can just like go inside your drink and like wrap around and get all the milkshake,
but
then it's incredibly efficient.
It's not, but it's a tongue, not a straw. So you just
no, but you can still, it's like licking the inside, you know.
Oh, okay, yeah.
Like licking your plate clean, but a glass. You could just tip it up and pour it into your mouth.
But like no one could tell because like you tip it up, but like it's not entirely melted, so some of it's stuck on the sides. And so you tip it up like you're drinking a Starbucks drink and no one can see your tongue, and then you just like shoot the tongue inside the inside and like whip it around and clean it. Unless it's like a clear cup and then they can see what you're doing and they'd be like, whoa, your tongue is like freaky, man.
So you just shoot your tongue in and whip it around. Got it.
Yeah.
Good advice. So.
Well, Steve wasn't offering any ideas for like when that would be useful, so I had to improvise.
Well, I implied it. You just said it.
Last fun fact, the sea cucumber can also secrete like toxins in the water to kind of ward off predators, but they can also play dead by expelling their organs through their bottom and then sucking them back up again. How would you like to do that?
No. I'm all good.
Well, this kind of makes me think of another evolutionary.
No, the answer's no, Thomas. You don't want to do it. There's no other. Let's talk about this. It's just no. Let's move on. I don't want to be able to protrude all of my internals out of my anus. Thank you.
I mean, I'm already an organ donor. It'd make it a whole lot easier to extract.
Do you want a kidney? Just let me just tense, and then you can just take it off me.
Well, I'm about to die anyways. Here, just put this heart on a thing of ice.
Imagine if humans
hang
were
on,
like
hang on,
this,
hang on.
though, and you're just like, you're at the pub, and this one really intimidating walks in, and just your stomach just falls out of your butt. It's just hanging there.
Apparently, there's porn stars that have had situations like that. It's a prolapsed anus.
Oh,
oh my god.
But it's not organs, but it is the anus comes out. So it's ridiculous. This
Oh.
I was just thinking,
like,
you know,
hemorrhoids.
you said
that's like next level hemorrhoids.
I know. You were saying that, you know, you could have the tongue which goes down basically into the bottom of your organs rather than at the top.
Oh, don't talk about sticking tongues in bottoms.
No. This is even weirder. If you had that and you had the ability, like a sea cucumber, to basically shit out your organs, if you mix those together, if you was to put your tongue out and then you was to also shit out your system and put your tongue in the opposite direction, you would be able to get further behind you with your tongue than you would in front. I just
what?
Because it's necessarily attached to the bottom, so it's going to be able to get out further.
Oh,
Mum, if you're listening, I'm sorry.
So you can like clean your organs, just like squirt your organs out, and then like reach around and your tongue's like, oh, I'll just clean my stomach real quick.
This is wrong.
But you know, it's if you think about. So Rachel, you were talking about
Rachel. When you decided to do this topic, is this how you expected the conversation to go?
No.
Okay, all right.
I thought
But
it would
if
be
you need-
fluffy monkeys and cute things.
let's say that you need, you know, your gut bacteria is all like, you know, dead or unhealthy or whatever, and you need a fecal transplant. You know, you need someone to put their poo in you.
Yeah.
Then if you could just squirt your organs out, then you could just like smear it like peanut butter, just like cover your your intestines with new healthy poo, and then just soak it back up in you, and then you'd have like a healthy microbiome.
And on that note, if you catch us next week...
Well, no, I wanted to cover one other area of defense mechanisms, and that we didn't talk about, and that's symbiosis, like symbiotic relationships. You mentioned the sea cucumber, and there's actually a fish that will crawl up inside the sea cucumber's butt and get to live in there.
Oh, that sounds like a fun life.
I don't know how it benefits the sea cucumber other than that he gets to have a fish live in its butt.
Does that... oh man, that's crazy. You get some parasites for fish that basically replace their tongue. They sever the tongue, become the tongue. So it doesn't benefit the fish at all. It's a parasite and their tongue's gone. However, the parasite lives very well because it's attached itself to that organism. The organism will bring food in so it can have I don't know the science of it all, but yeah, is it something like that?
There's areas, though, where there's cooperative relationships that aren't parasitic, like the crocodile bird that, you know, he gets to go in and eat the little bugs and gunk and crap that's like caught in the crocodile's teeth, and he basically functions as a dentist, and the crocodile gets his teeth cleaned, and the bird gets protection from other predators. Although I wonder if there's like a couple crocodiles out there that just haven't figured it out, and they're like eating the little guys like popcorn.
Yeah. Yes.
Oh no.
But then they live without
popcorn
free
birds.
dental care.
So, with this, to conclude, which animal would you like to be?
A human.
I quite enjoy being a human, yeah.
Not a sea cucumber?
Oh, you do get to have a fish in your butt. And you get to squirt your organs out.
What about you, Rachel? What animal would you be?
A tiger would be fun. Oh, no, an elephant. I think I'd like to be an elephant. Yeah, because I'd like to know what it's like to be that tall. That would be fun. And also, they're kind of like the opposite of me, because they seem like muscly and bulky and fun, but they're also still really playful. Yeah. And they have tusks, which just sounds fun.
So you want to experience being a gentle giant with tusks?
Yeah.
Be careful of poachers.
It's okay, I'll do that thing where they dye my tusks like purple, because then I'll be like a really trendy elephant and also safe from poachers. Yeah. Oh no, pink. I want pink tusks. That sounds more fun.
Yeah. Until Paris Hilton's, starts showing the new fashion trend of pink tusks.
Oh no. Do you reckon that could become a trend?
Rachel, with enough advertising, anything can become a trend.
I know, because that is like the worrying thing, because at first when I heard about it, I was like, this sounds great, this is going to save a lot of elephants and stuff. But then I was like, well, what if it becomes like a trend or like a trophy to be like, oh yeah, I've got one of these like dyed ivory tusks.
I don't think it will be, because it's so heavily frowned upon, and if it's obvious where the tusks and the ivory came from, then I think people would...
I thought that, but then you get people who are just so douchey. They don't care about the stigma, and they just want a trophy to be like, oh, look what I did. Like that douche who killed the lion. Yeah. Anyway, that's pretty much us done, and we are going to be back next week, where I predict Thomas will be talking about predicting the future.
Whoa.
Wow.
That was amazing.
It's almost like I knew we were going to do this.
This has been an absolute blast, and now we want you to join in the conversation over on the Here and How Facebook and Twitter pages, or follow us on Pinterest and Instagram if you just want some of the dankest of sciencey memes. If you like one of our particular styles, check out each of our YouTube channels: Rachel Oates, Rationality Rules by Stephen Woodford, and Holy Kool-Aid by me, Thomas Westbrook. To find all of our episodes, show notes, contact information, and more, warp on over to our home base, thehereandhow.com. If you enjoyed this episode and want us to succeed in spreading the love of science, you can help us out by giving us a 5-star review on iTunes or Stitcher. And to all our friends and family listening, thank you for spending this episode with us. We'll be back to explore another exciting big idea next week. Now go create something magnificent.